And I'm going to talk about the standard deviation of a population in a minute, but first I feel like I should tell you about something called the normal distribution. And so this is a concept that many biological populations follow this kind of distribution. So for example, if you look at the heights of people, it would be like this. So many biological populations follow this normal distribution. And so often we just assume that populations do. So it goes both ways. So very often if we're going to calculate the standard deviation of a sample, we'll assume that it follows a standard distribution. So what does this mean? So this here is the frequency on the y-axis. Now, then on the x-axis you've got the measurement values. And here's the mean right in the middle. So here's the average. And you'll notice this distribution is symmetrical. Excuse me. Around the mean. And so that means that the mean is equal to the median. So we have as many samples to the left of the mean as to the right of the mean. So the mean is the same as the median in your ideal normally distributed population. And so as I say, this is often true for biological data. I bet, for example, when you're measuring your aryl sulfatase activities in the labs, that your data would fit nicely to this. Okay, so now how does this relate to the concept of standard deviation? So in a normally distributed sample, we can describe that by standard deviation, which describes how spread out the measurements are. Okay, so here our measurement, this is standardized to the number of standard deviations, but even if they're symmetrical, that doesn't really describe how close together the measurements are. So if there's a small standard deviation, that means the measurements are close together. And a high standard deviation, measurements are spread out. This is in a normally distributed sample. And it has been calculated that 68.26%, this has all been calculated by clever mathematicians, so 68.26% of measurements are within one standard deviation of the mean. So that's what I'm talking about, this part. So there'll be an equal number of measurements between one standard deviation below the mean and one standard deviation above the mean, and then carries on. So we've got 95.44% of measurements within 2 standard deviations of the mean, and 99.73% of measurements are within 3 standard deviations of the mean. Okay, so normally distributed population, we've got this nice, we call it a bell curve, so nice even distribution of measurements around the mean, and we can predict how many samples are going to be within 1, 2 or 3 and so on standard deviations of the mean, because that's been worked out for us, and I'm going to show you in the next video how to calculate this standard deviation value.